All right, y'all, we left off last time getting somewhere between problem 8 all the way through the ready for the notes, but I want to talk about, before we move on to those notes, a couple things for every group here. Okay, so even if you finish this and we talked about it, I want to talk about it again because this is what tends to cause the most trouble for folks as you're working independently on problems. Okay, so we're going to reaffirm some of these things and then we'll talk about language for it here in a minute. So starting out, I've got the two sets of data for M1 and M2. Okay, what I want you to do for this is just to the side, we're going to add on the group that you don't have. So if you're an M1 person, I'm going to talk about that first, but you'll just hang tight, make sure your answers look correct and everybody's on the same page. And then we'll go switch the same for M2. Whatever data set you don't have, go ahead and do it with me here so that you get some extra practice looking at different values in a table. Okay, because they did end up looking a little bit different. So first up, it asks us to find the percent of all students who choose PE. First of all, this word of throughout here is going to indicate that the total follows it. So in this case, it says all students, we want the total to be all students in the class. I'm doing M1 first. There were 18 in this class. That goes on the bottom. Then from that group, we want to look at who chose PE. Now some of y'all used the table up above that only had electives because it wasn't talking about any core classes for this question. That's valid. I'm going to show you how it works the same way on this two-way table to give you the same value. If you go over to PE, taking your two sections and combining them together, you get 6 total students, and that matches the number of tallies that we had. Okay, so we've got 6 over 18, which is a third. It wants it as a percent, so 33.3 with a bar over it. Okay. From there, we're going to talk about the next one, percent of all students who chose math and chose art. So this and is going to indicate that we are looking for an intersection on our table. So we're looking for the intersection of math and art, and if that's our intersection, then our total back here really is just all students. Okay, so our all students over 18 one more time, and intersection of math and art on this one is 2 students. Okay, so 1/9 is 11.1 repeating, and those ended up being nice. Okay. This last one here is percent of the students who prefer math that chose tech. So that is another word that's going to show up. I'm going to give you another example here. That or given are two different words that could indicate that this is a conditional relative frequency here, which means we can't use the same totals as we did up there. We have to focus on what they tell us. Okay, so I want everybody to focus on this carefully because I do know when I was talking to a couple groups, I may have misled you here if I remember right and was talking about the process for given, which is not the same process for how this is worded. Okay, so let's get on the same page here and hopefully fix anything that I led you astray on. So here it says percent of students who prefer math that chose tech. So our percent of the students who prefer math is our total. It actually continues all the way through there. And that is telling us the condition that goes on top. Okay, so here, if we're trying to find who prefer math, we're looking in the math column, and that adds up to 14. So our total is 14. And then of those, we're focusing on who chose tech. The tech was just 2 of them. Okay, so here 2 out of 14 is 1 out of 7. 1 out of 7 is not a nice decimal. I think I still have it typed in here from earlier. Maybe not. And when you look at this, it is a repeating decimal. I'm telling you, all fractions are either repeating or terminating, but it takes a lot of digits for you to actually see it. Okay, you'll see this 1, 4, 2, 8. And then at the end it's 1, 4, 2, that 8 has been rounded up based on what's after it. Okay, we're not going to worry about writing that many digits, too many to repeat. So in this case, we'll just round. anytime we're rounding a percentage or relative frequency, anytime we're rounding in general, we'll just say we're rounding, and it doesn't give us guidance, so we'll do one decimal place like the others ended up being. So about 14.3%. Okay, this approximately tells me that I'm writing something different than my calculator told me the answer was. Okay, now we're going to do M2. So if you were an M2 person, you should have these values, but we're going to double check that, especially with this last tricky one, we're on the same page. And then if you were M1, you can practice along with us here. So this one only had 14 students in it, and we're going to do the same process. Our total will change then to 14. And again, this first one wants chose PE. So our PE row here is 5 and 3 together is 8. And then we've got 8 over 14. We're going to take a look at that as a decimal. Okay, again, this is a situation where it repeats, but it takes a while to repeat, so we're just going to round about 57.1. Next up, we've got all students, and again, it's an intersection, so our math and art intersection is this one. But it is all students, so we're going 1 over 14. Another ugly decimal there. So this one would be about 7.1%. And that last one. Okay, making sure we're going in the right order. Percent of the students who prefer math. So we're going in this column only. We've got 11 total in that column. And from those, we're looking at who chose tech. So from that tech 3, we're going to just divide that in and see what our approximate relative frequency is. Okay, this is a nicer repeating value, so if you wanted to use 27.27 with the bar over both, you can. If you wanted to round consistent with these other one, that's fine. Okay, so I'll show both here. You can say approximately 27.3%, or you can say exactly 27, and that 27, the whole thing repeats there. That's it. Okay, so part of this was understanding where to look at things, but another part of it is going to be when we know to do each process and how we classify them with names. And that's going to come into play when we talk about some vocab here in a bit, and I'll come back to these. Okay, I do want to talk just a little bit about the graphs, specifically the segmented ones, and it kind of deals with what we were just talking about of a conditional probability or conditional relative frequency that's happening. Okay, I use the word probability because it deals with this association down here below. Okay, but first, I just want to make sure we all know why Excel looks the way it does for these different percentages. Okay, so when we were looking at M1's data, this whole, the math section was kind of distributed into all of the different electives, but English only had 2 of them. Okay, similar over here, math had more of the electives chosen, and English just had 1, in fact. So this bar I'm going to start with is talking about 100%, and it's focusing just on English. Okay, so if I go back to that table of values, it's saying from my English column I have 3 total people, and I was just focusing on one particular group. That was talking about PE. And 3 out of 3, so 3 people who were in PE and English, that was the 100% of the bar. And there was no other groups available. Okay, this other column here was the remainder of the people. This was our 11 humans who were left. The first section is the 1 out of 11, then 2 out of 11, 5 out of 11, 0, that was why there weren't all of them, and 3 out of 11. And that's why, realistically, here your sections look the size they do. Okay, so that's based just on the math group. Similarly, over here, when we talk about this breakdown, these percentages are only talking about the people who chose math as their favorite core class, which means the total for all those percentages were calculated only out of these 14 people. and the English categories were out of these ones. And I want to point this out because it's pretty easy to calculate these mathematical proportions. If the total was 4 here, you see 2 over 4 is a half, 2 over 4 is a half, which means music and PE should be half and half for that bar, and that matches exactly what was going on in the graph. Okay? So association just talks about if I were to focus on math, would I be able to see from the graph an association between that and a particular elective? Okay, so when I'm asking you a question like this, there's not necessarily a right answer. I just want you to tell me what you notice. Okay, so association means choosing one thing will make it more likely for something else to happen or less likely for something else to happen. Okay, so I'm going to go over to this English one over here because we can see it pretty obviously. On this one, choosing English as your favorite makes it 100% likely in this particular class that their favorite elective is PE. So there is an association with that. Okay, that's just one example. You can describe any trend that's happening that you see there. Okay, if there's not an association happening, okay, we want to know what that would look like instead. Okay, so if you chose English, or say you chose math, and there's not an association, we're looking at what that would be. For us, that's going to mean your different segments for your favorite elective should be more equally distributed. Okay, so the proportions of those segments are going to be more evenly distributed. Okay, and that's not going to be perfect. It's not going to say that there would be an equal amount in each. We know in practice that doesn't happen, but they would be more even than seeing that 50-50 or 100% on one. Now I do want to talk about one more thing, and I talked about this with a couple groups, but when we look at our individual data, you'll notice that the majority of our people in both sections chose math as their preferred core class over English, and I hope that's to be expected. This class in particular is a special case. If we would redo this simulation with the rest of the Hayes High student body, we may not see the same types of results splitting them into these categories. Okay, the reason that this class is special is because this class is something that's considered optional for juniors. They have other options. They have different math classes they could take that are less rigorous in terms of advancement level. Okay, so because of that, choosing to be in this class, I would assume that we would have a higher proportion preferring math over English. Okay, but there's this such thing as, you know, they just like English better. Maybe I'm good at math, but I prefer English. Or you're in this class because you're a sophomore and you didn't know what else to take. Okay, so lots of different options there, but I did want to mention this. This two-way table is going to definitely look a little bit different than a traditional layout. Okay, traditional layout, I would assume that my English people would maybe be more heavily in art, music, maybe foreign language, and then your math people are more tech and potentially PE. This one's kind of hard. PE could go either way, in my opinion. Okay, but that's kind of a traditional layout, one would assume. And now we're going to talk about the vocab. Okay, a two-way table is just a way to organize two variables. And oftentimes the purpose of using a two-way tables is to recognize association. see if we see any patterns. All right, marginal relative frequency, joint relative frequency, conditional relative frequency. And I've already used this word, but now we're going to talk about these other ones. A marginal relative frequency only looks at one of the variables. Okay, so instead of writing a formal definition, I'm going to write the math for it. Okay, so if we're doing a relative frequency, we're always over some sort of total. And if it's a marginal relative frequency, it's in the total. Biggest, all groups are included, but we're only focusing on one variable at a time. A joint relative frequency, this joint means together. That means we're looking at both variables together, so two variables over our total. Okay, and our two variables are, remember, going to show up in an intersection. And a conditional relative frequency is going to be one variable given the other variable. Total. Okay, so this one, conditional, you're going to say given, or you're going to see that. Joint, you're going to see and this one, really, you're just going to see a regular of. All of these have of, but the top one is more straightforward than any of the others. So with that in mind, we're going to go back real quick to number 5 and make sure we can classify each of them based on what we're seeing. Okay, so number 5, we had of all students who chose PE, there is just one variable, and so that would make it a marginal relative frequency. Okay, when we're talking about math and art, there are two things together. The word together is joint. So this one is joint relative frequency. And finally, it's of the students who prefer. Okay, so of one variable, we're looking at the other variable. That is your conditional. A conditional relative frequency will always have you narrow the total on the bottom down to a single row or single column total value. And now we're going to practice. Okay, so the back side here is just checking that we understand all the things that we just talked about. Okay, we just did the vocab of these things. I'm giving you context to a new situation. What I'm going to have you do right now is pause the video and try these problems. It's okay if you talk with the person next to you for this, if they're at the same point as you. And then once you're done, go ahead and hit play again and you can check your answers. Okay, so what I did here on my table, and this may be beneficial for you, take it or leave it, is added total columns and row sections to it to kind of make these problems easier. Okay, before we were only asking a couple questions that would involve total values that weren't already there, but this one we've got 4 different questions and it kind of makes it easier for us to see everything. Now I wanted to do this even though we didn't use every single section here, just to show you that when you're talking about the totals of the columns going down and the totals of the rows, when you add those together for a two-way table, you should get the same final total. So this going across should equal this going down. Okay? Otherwise, something went wrong in terms of how you were calculating it. Okay, but now we can look at the problems we were asked for. I've kind of indicated some of these sections here that should be helpful. It says for this first one, the of, that remember is going to tell you the total follows it, and we're just focusing on that junior column, so 51 is our total for that. And from there, we're doing the currently working section, that 14, and about 27.5%. Now I wanted to relate this back to the mosaic plot. Don't forget that's the name of this guy. And within this junior section, that was our total here, it relates directly to this bar talking about that currently working. Okay, so that is how they're calculating those proportions, and they're doing it with a conditional relative frequency, because your condition is we're focusing on just the juniors, and then from there breaking it into the different groups. The same thing happened on the next one, except we're looking at the seniors, so our total value is 80, and we're focusing on the section not working but have a job, nice 50% there. Okay, both of those were conditional relative frequencies. On the next one, we have of upper level students. Okay, if you were reading the given information here, it said talking about upper level students, thinking about juniors and senior, those are your upperclassmen. So that's the total. They use different language, but that was everyone, all of the students that were sampled. Okay, and from that total of 131, we're concentrating on the never had a job section. So that showed up in our row heading. We're going all the way over to the end of a row. Okay, this was our one, like our problem where I said it just focused on PE, just focused on favorite electives, so we could have used the one variable type. We just have a two-way table, so all the way to the end of the row, that value there. Okay, and then on that one, because it's only one variable, we're classifying it as a marginal. Okay, marginal is always used when one variable is looked at. Last one here with our calculations, this one was of students surveyed, so again that's the 131, and we're focusing on seniors who have never had a job. So this didn't directly say the word and, but when we're saying seniors who have never had a job, that's they are a senior and they have never had a job. Okay, so that's implied language. We may see it written like this instead. Okay, look out for those for another way joint relative frequencies can be displayed. Very last thing you were asked to do is just summarize the display, another one where it's not necessarily a right answer. You're going to tell me something that's true about the graph, and specifically with associations. So when I'm talking about associations, I like to look at bigger discrepancies between the two categories we're focusing on. Okay, so the things that look the most different are the sections in orange here and the sections in dark blue, because the sections in the middle are relatively equal in terms of the height. Remember, the width indicates that there were more seniors than there were juniors. If you go back to your columns, we had 51 and we had 80, so there were more of those seniors. Okay, and that width of the bar is just related to that different size proportions. Okay, so if we just pick on one thing, and remember you can write anything you want here that's coming from here, we may say that there is an association between grade level and employment status, because I see that juniors are more likely to have never had a job than seniors were. Okay, similarly on the reverse side over here, I can say seniors are more likely to be currently working than juniors are. Okay, so something you see that's true. What you're going to do now is take the homework that I gave you last time and work on it for the remaining of class. If you do have any questions, there's a couple options. You can go up and check the key to see where you're at, give you some backwards guidance. You can work with each other through problems. And then if you're still stuck after that, please feel free to email me. I should have my phone on me to answer those when I get a chance.